In this video, I would like to offer a simple lesson on measurement and fractions. This is something that students in the past have asked for, and it's not something that everybody is automatically good at. I know that you learn fractions when you learn arithmetic in primary school or elementary school, but if you don't use them, you kind of forget how to use them as a tool. And so since all of the measuring that you're going to be doing in the shop is going to be based in fractions instead of decimals, at least that's the easiest way to use the measurement tools, I think we should go over it. So the first thing I'm going to do is I'm going to show you a bunch of different measurement devices, and then we'll go through just the simple fractions of the inch so that you can get more familiar with them. This is very useful when you're building something because you don't want to have to stand there and think for a long time, is that 5/8? Is that 3/4? What is that mark? You need to be able to just recognize it. So first off, the simplest measuring device is the tape measure. Now, this is a tape measure for carpentry, woodworking, metalworking, and it comes in the little box, right? And it has a little brake on it, so you can leave it stand out, and then when you pull the brake, it disappears. If you're using a really large tape measure and you have it extended more than, say, 4 or 5 feet, when you let that brake off, be very careful because it can snap back and sometimes cut you or hit you. So just be careful. Sometimes they spring back very quickly. Now, if you're doing any kind of work with sewing or tailoring, you're probably using a different kind of measuring tape. And that is usually called a tailor's tape. It's not in the little box, and it's flat, and it's usually anywhere from 4 to 6 feet long. So different kind of tape measure, basically does the same thing, but you wouldn't want to use a tailor's tape to do woodworking, and you wouldn't want to use this kind of tape measure to do any kind of sewing or cutting of a pattern, fabric. Okay, so there's a whole bunch of different squares in the shop. We have a fixed square. This has inches measurement on it, and you can check the square of an angle. We have a sliding square. We have all of these other funny little measurement gauges to measure the diameter of a drill bit or the notches of, say, a dovetail or something like that, or different nuts and bolts. So there's a lot of different measuring tools around the shop. The ones that we use most often are in the standard measurements, which is inches, feet, yards, things like that. There are some things around the shop that have centimeters on them, and if you can help it, I wouldn't use those. Go ahead and use everything in standard measurement. The only time that you would definitely have to use metric is if you were using the socket set and you found that a bolt you were removing from a bicycle or some other piece of machinery was in metric. Then you'd have to go through and figure out what the measurement was in metric. But you can do that by trial and error. I will say the metric system is easier to use because it's based in tens. And when I was a little kid, America was talking about switching to the metric system. And sometimes I wish we had. So at any rate, let's take a look at the inch measurement and talk about the fractions in that. Now, in the shop here, I have this little tool for helping you to remember those fractions. And I've just taken this piece of scrap wood and I've written out some of the basic fractions on it. Now, I haven't written them all out. I've only written out the first example of each. So we have a 16th, an eighth, a quarter, and a half. Now, you can go smaller than a 16th. You can go down to a 32nd or 64th of an inch. It gets very difficult to count those out. And for most of the work that you're doing, if you're within a 16th of an inch, you'd probably be okay. If you're doing really fine woodworking, you would want to be within a 32nd of an inch. Once things are off more than a 32nd to a 16th of an inch, they might not go together right. For instance, if you're making a picture frame and one side of the frame is a 16th of an inch longer than the other side and it's supposed to be square, you're not going to get a good square. And so when you go to check the square with your fixed square or your sliding square, you will notice that it's not quite square. And if you're 1/8 of an inch off, it's probably not even going to fit together well, and you'll have a big gap at the corner. So it does pay to measure things out really well. Aside from just doing fractions and arithmetic to take measurements, you'll also run into some simple geometry. Now, I will tell you this, I was never very good at math, especially higher math. If you made me take an algebra test right now, I would probably cry. But I'm pretty good at arithmetic, and I've gotten really good at fractions because I've been a carpenter for so long and done so much work on houses and remodeling and things like that. But simple geometry is something that also comes in handy a lot. So we have a set of tools here for that as well. We have some different drawing triangles and protractors. Now, these are great for drawing things out, making a plan, drawing things out on paper. You can even use these to draw things out on wood. But once you get to the stage where you're going to start cutting, get these back on the wall because they're just plastic and they're easy to break. And even if you start wearing off the corners, they don't work so well. And keep these out of the metal shop because a piece of hot slag will burn right through them. So one of the places that you'll run into this kind of simple geometry most is building frames and boxes. I mentioned checking something for square. If you think about a box or a frame that has 4 sides, each of those sides, if you want it to be square or a rectangle, then each of those sides needs to be a 90-degree angle. 90 times 4 adds up to 360. That's how you go all the way around, right? Now, if you're mitering on the saw and you want to have a corner that meets with an even seam in the middle, that means that you're cutting those at a 45 because 2 45s equal a 90. So you see how the geometry starts to work out here. I challenged myself last year to make some very irregular frames, and this relates to some of the artwork that I've been making on my own at home. And those irregular frames have no regular angles or measurements and no regular lengths to the sides. They're all different. But through the process of elimination and simple geometry, once all of your angles add together to make up 360, it all comes back together and it fits and makes a nice solid piece. So you can figure this stuff out. If you need help, come and talk to me. And obviously, you can always Google it because there's plenty of simple geometry equations online that'll help you out. Tons of builders go through the same thing. Someone who's building a house and has to figure out the pitch of the roof needs to know simple geometry. So plenty of resources out there, and let me help you if I can.